this session on important MCQs for the board exam term 1. In this video, we'll discuss about electric charges and field important MCQ questions. So the first question is, a force of 4 Newton is acting between two charges in air. If the space between them is completely filled with glass, then the new force will be. So let the two charges be located at A and B. Okay, and the force when it is two charges is in air, then it is 4 Newton. Okay, in air it is 4 Newton. So when the charges are placed in glass, between the glasses, then what will be the new force? Okay, so the relation between this new force F dash is equal to F divided by the dielectric constant of the material. Dielectric constant of the material K is equal to 8 by K. So therefore we'll get 4 divided by 8. So which is will be equal to 1 by 2. So which will be equal to 0.5 Newton. So the new force will be equal to 0.5 Newton. Option is D. Okay. So important relationship is new force will be equal to F divided by the dielectric constant. Next is charge Q is placed at the center of the line joining two equal charges. Okay, there are two equal charges, Q, let it be Q. Okay, and the charge Q is placed at the center of the line joining the two equal charges. Okay, let the midpoint be C and the charge Q is placed at the midpoint. The system of three charges will be in equilibrium. So when this charges will be in equilibrium. So for equilibrium condition for the system, the force between A and B, force between A and B plus the force between A and C should be equal to 0. Okay, that is force FAB should be equal to minus FAC. Okay, so there will be a repulsive force between all the charges because all the charges are positive. So force between A and C will be a repulsive force, force between B and C will be the repulsive force, and the force between A and B also will be a repulsive force because all the charges are positive like charges. So by Coulomb's law, what is F? F is equal to K into Q1 into Q2. So here QA into QB divided by the distance. So here let the distance between A and B be 2x. Okay, then the distance between A and C will be equal to x. Okay, A and C will be equal to the total distance between A and B is 2x. So the distance between A and C will be x and distance between B and C will be x. So what is Coulomb's law? F is equal to K into Q1 Q2 divided by R square is the Coulomb's formula. Okay, so for FAB will be have K into QA QB divided by, for A and B it is 2x. So 2x the whole square is equal to minus of K into QA QC divided by x the whole square. Okay, so we can cancel out the common terms. Okay, K gets cancelled. Okay, now we can substitute the values. What is QA values? Q. So QB value is also Q. So Q into Q will get Q square divided by 4x square. So which is equal to, what is QA? Charge at A is Q and the charge at C is small q divided by x square. Okay, now we can cancel 1q. Then we have, from this we have q by 4x square is equal to q divided by x square. Okay, so we can cancel this x square. Therefore we have to find out from the question what is small q value. So we have q by 4 is equal to Okay, the left minus sign, sorry, I left out the minus sign will be coming here. So q by 4 is equal to minus q. Therefore, q will be equal to minus of q by 4. Okay, just substitute the values in the Coulomb's formula. Then we'll get q is equal to minus q by 4. So the option will be B. So just equate the charges. Okay, and the condition for equilibrium. So FAB plus FAC is equal to 0 or FAB plus FBC is equal to 0. Next is 2-point charges Q and minus 3Q are placed some distance apart. Okay, so let it be charge Q and this be minus 3Q. Okay, are placed at some, if the electric field at the location of Q is, okay, if the electric field at the location of Q is E. Okay, they are given electric field at Q is E, then the field at the location of minus 3Q. So let the field at A is, at A, let the field be E. Okay, at B, let the field be E dash. Okay, so we have to find out what is E dash. Okay, so for this, apply the formula for electric field at a distant point R. So what is the formula? E is equal to K Q divided by R square is the formula for electric field at a point due to a charge. So what is, first we can find out what is E. Okay, at A. At A, what is the electric field? E will be equal to K into this charge 3Q. Neglect the minus sign because electric field is a vector quantity. Just consider only the magnitude alone, divided by R square. Okay. Now, what is the electric field at B? At B, what is the electric field due to A? At A, what is the electric field due to B? At B, what is the field due to A? So, at B, E dash will be equal to K into charges Q at A divided by R square. Okay. So now you have to let this equation be 1 and let this equation be 2. Just divide. Okay. Divide the second equation by 1. 2 divided by 1. So what is the second equation? E dash is equal to K Q by R square. Okay, divided by the first equation is E divided by K 3Q by R square. Okay, just cancel out the common terms. So K gets cancelled. Okay, Q gets cancelled. R square gets cancelled. So E dash by E will be equal to 1 by 3. From this we can write it as E dash is equal to E by 3. Okay, so just we have to substitute in the electric field formula. E is equal to KQ by R square. For each location A and B equated, we'll get E dash is equal to E by 3. Option is C. Okay, next is soap bubble. Okay, is given a negative charge. So have a negative charge in the soap bubble. Then its radius. Okay. So due to this, all the charges, due to symmetric property of this bubble, okay, all the charges will repel because all the charges are negative. So each charge will repel each other. So negative charges repels, that be a repulsive force in this along the surface of the bubble, right? So due to this, what happens? Due to repulsive nature, each charge will repel each other, right? So when it repels each charges, okay, what happens? The radius gets increased. Radius increases. Okay, so decreases, increases, radius will increase because due to symmetry property of the bubble, okay, of the charges, all the negative charges will repel, each charges will repel one another. So the radius increases due to repulsive force of the charges, negative charges present in the bubble. Exist two equally charged identical metal spheres A and B repel each other with the force F. Another identical uncharged C is touched to A and then placed midway between A and B. Okay, now two equally charged identical metal spheres. So A and B are two identical metal spheres. So let the charge we can consider to be Q at both A and B. Okay, now we are taking an uncharged sphere C. Okay, let C is uncharged and is touched with A. This is charged with a charge of Q. So we are considering a charge Q. So identical charge A and B. So both the charges will be QQ. Okay. Now due to this conduction, okay, charging by conduction, because they are touching, they are in contact. So what happens? The charges will be equally distributed. Okay, Q is a charge at A, will be equally distributed, means Q gets distributed as at A and C, the charge will be, Q will be equally divided, Q by 2, Q by 2. Okay, for conduction process, charge will be transferred equally from A to C, so the charges will be equal at A and as well as at C. Okay, so now the charge of C will be Q by 2, charge of A will be Q. Okay, so what will be the force due to the C? A will repel the C. Okay, A will repel the C towards B. So C is repelled by A. Okay, and similarly, what B, between B and C is also like charges, both are positive. So B also will repel the C towards A. Okay, so force will be towards B as well as towards A because of the like charges. So answer is option A. Okay, so in this question, we have an electric dipole when placed in a uniform electric field will have minimum potential energy if the angle between dipole moment and electric field is. Okay, so electric dipole, okay, potential energy for an electric dipole will be minus PE cos theta. Okay, this is the formula. So first, from the choice you can substitute the values. They are given us when the theta is 0 degree. So when you substitute for 0 degree, you will get U is equal to, what is cos 0? Cos 0 value is 1. So you will get minus PE, okay, into 1. Next for pi by 2. What is cos pi by 2? Cos pi by 2 value is 0. So you'll get the U is equal to minus PE into 0 will be 0. Next for cos pi, the value will be equal to minus 1. So U is equal to minus PE, cos 180 will be minus 1. So minus into minus will get plus PE. Okay. Next for cos pi by 3, that is for cos 60 degree, the value will be equal to 1 by 2. So U will be equal to minus PE by 2. Okay, now compare all the values. So we want to find out which has minimum. Okay, so which will be minimum? For cos 0, U is equal to minus PE. So this has the minimum value when compared to all other values. So the option will be A. A is the answer. Okay. Now an electric dipole consists of two opposite charges of a magnitude of 1 microcoulomb separated by a distance of 2 centimeter. Okay. The dipole is placed in an electric field 10 to the power of minus volt per meter. The maximum torque experienced by the dipole. So it is placed in a uniform electric field. So you have to find out for maximum torque. Okay, for uniform electric field, dipole is placed in uniform electric field. So what are the given values, sir? The charge values is 1 microcoulomb, which is nothing but 1 into 10 to the power of minus 6 coulomb, and the distance they have given us L is equal to 2 centimeter. So which is equal to 2 into 10 to the power of minus 2 meter, and the electric field E is equal to 10 to the power of minus 5 volt per meter. Okay, so now what is the formula for dipole electric field maximum torque? So what is the maximum torque? Tau maximum we have to find out. Okay, so tau is equal to PE sin theta is the formula. So for tau maximum, theta should be equal to 90 degree, because sin 90 will be equal to 1. So we will get maximum at theta 90 degree. Okay, so for tau max, theta equal to 90 degree. So we'll substitute here PE sin 90 degree. Okay, this will be a tau maximum. For tau maximum, theta equal to 90 degree. Okay, that is the angle found between the electric field and the dipole will be 90 degree. Okay, now substitute the value. What is P? P is the dipole moment. So dipole moment is Q into L. Okay, into E you have into this sin 90 is 1. Okay, now substitute. What is Q? Q is equal to 1 into 10 to the power of minus 6 into L is 2 into 10 to the power of minus 2 into E value will be equal to 10 to the power of minus 5. Okay, so you'll get 2 into 10 to the power of minus 30 Newton meter. Okay, minus 2 minus 5 minus 7 minus 6 will get minus 30. So 2 into 10 to the power of minus 30 Newton meter. So option is B. So substitute the torque formula. T is equal to PE sin theta. Since they asked for maximum torque, we are substituting theta equal to 90 degree. If it is minimum torque, then you have to substitute theta equal to 0, because sin 0 will be 0. Okay, electric field line provide information about. So, for example, consider there are two charges, minus Q and plus Q, and these are the electric field lines. So, for positive charge, electric field line will be away from the charges, and for negative charge, the electric field lines will be towards the charges. So, it gives the field strength. Okay, closely spaced lines will give you the field strength. Here they are closely spaced. So, they give the field strength, okay, to be maximum, and the widely spaced, we say that field strength is minimum here when compared to here. Okay, so wide. So what are the information you get? Field strength. When they are closely spaced, we say that field strength is maximum. Direction, they give the direction of the charges. Okay, nature of charge, whether charge is positive or negative. Based on the direction, you can say the charge is negative or positive. If the direction is towards the charge, field lines have, these are the field lines, right? So when the field lines have the direction towards the charge, then we say that the nature of the charge is negative. When it is away from the charge, we say that the nature of the charge is positive. So field strength, direction, nature of charge, everything information is given from the field lines. Okay, it is an imaginary line. So all of this. Excess based questions. They are given the smallest charge that can exist in nature is the charge of an electron. During friction, it is only the transfer of an electron which makes the body charged. Hence, net charge on a body is an integral multiple of charge on an electron. Q is equal to plus or minus NE, where R is equal to 1, 2, 3, 4, etc. Not R, where N is equal to, okay, 1, 2, 3, 4, etc. Hence, no body can have a charge represented thus. 1.8, 2 points, a fraction part is not allowed. Recently, it has been discovered that elementary particles such as protons or neutrons are elemental units called quarks. Okay, they are given charge Q is equal to NE, and N should be the integral multiple of charges. So, which of the following properties not satisfied by an electric charge? Total conservation of charge? Yes. Okay. Then quantization of charge? Yes. Two types of charge? Yes, we have electron and proton, positive and negative. Circular lines of force. Okay, this property is not satisfied by the electric charge. Option D is not satisfied. A, B and C is satisfied and D is not satisfied. So which is not satisfied is option D, circular line of force. Next is which one of the following charge is possible? Okay, 5.8, 3.2, 4.5, 8.6. So we know that charge of any object is equal to n into E, integral multiples of E. So what is E? E is a charge of an electron is 1.6 into 10 to the power of minus 19 coulomb. So the charge should be the multiple of 1.6 into 10 to the power of minus 19 coulomb. Okay, so Q charge of any object should be the multiple of 1.6. So we can substitute and we can check down which has the value. Okay, so now we can check for first n is equal to, when you substitute for n is equal to 5.8 into 10 to the power of minus 18 divided by 1.6 into 10 to the power of minus 19. Then we after dividing we'll get answer as 36.25. Okay, similarly divide Q by 3.2 into 10 to the power of minus 18 divided by 1.6 into 10 to the power of minus 19. So we'll get 20. Okay, for 4.5 we'll get 2.8 after dividing, and for 8.6 after dividing we'll get 5.3. So now compare all these things. What I have said, Q should be equal to n into E, and n is always integers, not fraction. So from this value we get only for 3.2 we get 20, for all others we get a fraction part. So option is B. 3.2 into 10 to the power of minus 18 coulomb is the answer. Okay, if a charge on a body is 1 nanocoulomb, then how many electrons are present in the body? Okay, charge on a body Q is equal to 1 nanocoulomb, which is equal to 1 into 10 to the power of minus 9. Nano is minus 9 coulomb. Then how many electrons are present? We know E is equal charge of 1 electron is 1.6 into 10 to the power of minus 19 coulomb. So Q is equal to N into E. Okay, so 1 into 10 to the power of minus 9 is equal to, we have to find N equal to 1.6 into 10 to the power of minus 19 coulomb. Therefore N will be equal to 1 into 10 to the power of minus 9 divided by 1.6 into 10 to the power of minus 19. Okay, so we'll get the answer as 0.625. Okay, into 10 to the power of 10. Here the option is in terms of 10 to the power of 9. So just multiply and divide by 10 will get answer is in terms of 6 point. Okay, so just multiply, you will get 6.2. Multiply and divide by 10 will get 6.25 into 10 to the power of 9. Okay, this is your answer. Just adjust the powers, okay, to make it 6.25. So the answer is option D. Okay. Okay. Okay, up to this we have discussed the important problems. So and okay, 9 and 10 problems I left out, so I just will see this now. There are two charges, 1 millicoulomb and 2 millicoulomb, kept at certain separation. The ratio of electric static forces acting on them. So two charges are there. One is 1 millicoulomb and another one is 2 millicoulomb. Okay, separated by a distance. Okay, then the force. Then we know that from the Coulomb's law, F is equal to K into Q1, Q2 electrostatic forces, K1 the product of charges divided by the square between them. So let it be A and let it be B. Okay, both are like charges, so A is repels B and similarly B will repel A. Okay, repelled by B Okay, and we also have A is B is repelled by A. Okay, two equal charges. Okay, this is the force that repels B, and this is the force that is repels A. So what could be the ratio of these charges? Okay, just find out. So both are repulsive forces, so FAB will be equal to FBA. So substitute K into QA QB divided by R square is equal to K into QB QA divided by R square. So even if you substitute the values, left side and right side will be equal. So K into QA is 1 millicoulomb, 1 into 10 to the power of minus 3, and QB is 2 into 10 to the power of minus 3. By seeing this itself, we say both the left side and right side are equal. So you can cancel out both the things. Separate by some resistance R square is equal to K into 2 into 10 to the power of minus 3 into 1 into 10 to the power of minus 3 by R square. Okay, now both the left side and right side are equal. Okay, so K, everything 2 to 1, 1, R square, everything gets cancelled. So we'll get the ratios 1:1. Left side, right side are equal. So because both are repulsive force, since both are positive charges, repulsive force, so FAB will be equal to FBA, so we'll get 1:1. So answer is C. Okay, next is next question is electric field on the axis of a small electric dipole at a distance r is E1 and E2 at a distance of 2r. Okay, the electric field of a dipole. So let Q and minus Q be the two charges. That is electric dipole, right? Two equal and opposite charges separated by a short distance. And along the axis, okay, along its axis line, the distance from the center is r. This is the axial point. Let P be the axial point along the axis of the dipole, and perpendicular bisector is along the perpendicular midpoint, perpendicular at the point B A. This is a perpendicular bisector point. It is separated by a distance of 2r. Okay, this you call it as equatorial point. So at a point that is perpendicular to the two charges of the dipole, we call the equatorial point, and the point that is along the axis we call axis point. So it is a distance of 2r. Okay, so now that we know the formula for axis, electric field at the axis. Okay, electric field at the axis is equal to 2 kp divided by r cube. Okay, and the electric field at the bisector, okay, perpendicular bisector equatorial point will be equal to minus kp by r cube. Okay, here the distance is r, from here the distance is 2r. So this is the formula, but we have the distance r is equal to 2r. Therefore, E equatorial we have minus kp divided by 2r the whole cube. Okay. Now we have to find out what is the ratio of E1 and E2. So E axis is E1 and E equatorial is E2. Okay, this is given the question. So E1 divided by E2 will be equal to 2 kp by r cube whole divided by minus kp divided by 2 r cube is 8, 2 cube is 8 r cube. Okay, so we can cancel out the common terms. K gets cancelled, pp gets cancelled, r cube gets cancelled. Okay, so we'll get E1 by E2 is equal to, if you cancel this, 2 into 8 will get, right? So this is 2 by 1 divided by minus 1 by 8. So we'll get 8 into 2 will get 16. Okay. So E1 by E2 will be minus 16. Just we can neglect the sign. Will be 16. This negative sign denotes that for the equatorial, at the point at the perpendicular, the electric field will be opposite to the dipole moment. Okay, this negative sign denotes at electric field at the equatorial point, the electric field will be opposite to the dipole moment, will be from minus q to plus q. Okay, if it is minus q and if it is plus q, the dipole moment will be like this. So opposite and denotes. So when you take what value, will get 16. So option is D. Okay, the continuation of case study and assertion problems will be given in the next video. So kindly watch the next video. Kindly share with your friends. Thank you. We can see in the next set of questions based on case study and assertion questions. Thank you.